Hello, this video is on the surface area of solids with curved surfaces, as shown here in the syllabus. You will find the formulas for area and the area of a curved surface on page 2 of your formula booklet, as well as on page 6. The surface area of a solid is the sum of the areas of all its surfaces. These solids have curved surfaces, but the surface area is still the sum of the areas of all its surfaces. The curved surface of a cylinder is rectangular when rolled out flat, and the length of the rectangle is actually the circumference of the cylinder's circle. So the curved surface area of a cylinder is 2 pi r times h, where r is the radius and h is the height of the cylinder. The curved surface of a cone, when laid flat, is a sector of a circle of radius L, where L is the slant height of the cone. The curved surface area of a cone is equal to pi times r times L. The curved surface area of a sphere is given by the formula 4 pi r squared, where r is the radius of the sphere. The curved surface area of a hemisphere is equal to 2 pi r squared, where r is the radius of the hemisphere. Surface area is the same as the area of the net required to make the figure, and the net of a cylinder is shown here. It is made up of a circular bottom and a circular top and a rectangular curved surface area. The surface area of a solid cylinder is equal to 2 pi r h plus 2 pi r squared, where r is the radius and h is the height of the cylinder. The net of a solid cone is shown in this diagram. It is made up of a circular base and a curved surface in the form of a sector. The surface area of a solid cone is equal to pi rl plus pi r squared, where r is the radius and l is the slant height of the cone. The surface area of a solid hemisphere is in 2 parts, a hemisphere shell and a circle. The surface area of a solid hemisphere is equal to 2 pi r squared plus pi r squared, which is equal to 3 pi r squared, where r is the radius of the hemisphere. In this question, we're asked to calculate the surface area of the ice cream cone. If we start by identifying the slant height, L, as shown, and then identifying that Pythagoras' theorem can be used to find L, which is the hypotenuse of the right-angled triangle shown. Substituting in the values and solving the equation gives the value shown. To calculate the surface area of the ice cream cone, use the formula for the area of the curved surface of a cone, as given in your formula booklet, which is pi rl. Substituting in the values and performing the calculation gives the value shown. The ice cream cone is open at the top and so has no circular base. The surface area of the ice cream cone is therefore 80.5 centimeters squared, correct to 3 significant figures. In this question, a solid cone has a total surface area of 300 centimeters squared, and we're asked to find the slant height of the cone. If we begin by finding the area of the circular base, substituting in the value of the radius, and performing the calculation, gives the value shown. Then writing down the total surface area, That's the area of the curved surface and the area of the circular base, substituting in the values of A, surface area, and R, radius, to form an equation involving L. You can either solve the equation algebraically or use Solver on your calculator. To use Solver, from the main menu, select Equation, and then press F3, Solver. Type in the equation to be solved. So enter in 300, pressing Shift to access equals at the bottom, and then again Shift to access pi, also at the bottom, multiplying by 5, multiplying by pressing the X variable button to represent L, and adding on 25 pi. Press Execute to enter the equation, remembering that the number next to X is not the solution to the equation, as we haven't pressed Solve yet. Press F6 to solve the equation, giving the value shown. So the slant height of the cone is 14.1 centimeters, correct to 3 significant figures. In this question, we're asked to find the total surface area of the solid hemisphere shown. If we begin by finding the radius of the circular base, remembering that the radius is 1/2 of the diameter, so the radius is 6 centimeters. This is also the radius of the hemisphere. To find the area of the circular base, write down the formula for area of circle, substitute in the value of the radius, 6 centimeters, and perform the calculation to give the value shown. To find the area of the curved surface, write down the formula for the area of the curved surface of a hemisphere. Again, substitute in the value of the radius, 6 centimeters, and perform the calculation to give the value shown. To find the total surface area, add these two values together. Performing the calculation gives the value shown. So the total surface area of the solid hemisphere is 339 centimeters squared, correct to 3 significant figures. In this question, the total exterior surface of the grain container shown is to be painted, and we're asked to find the area to be painted. If we begin by identifying the surfaces to be painted, the curved surface of the cylinder and the curved surface of the hemisphere both need to be painted, but not the bottom and the top of the cylinder or the base of the hemisphere, as they're not exterior surfaces of the grain container. For the cylinder, with a radius of 3.5 meters and a height of 7 meters, writing down the formula for the curved surface of a cylinder, substituting in the values, and performing the calculation gives the value shown. For the hemisphere, with a radius of 3.5 meters, writing down the formula for the curved surface of a hemisphere, substituting in the value of R, 3.5, and performing the calculation gives the value shown. Adding these two values together, remembering to use accurate values, gives the value shown. So the area to be painted is 231 meters squared, correct to 3 significant figures.